from its surface and construction to its uniqueness in regards to moons and more. Join us as we reveal to you Triton, Neptune's weird moon facts and history. Number 6. Discovery and naming. When it comes to the discovery of planets and moons, many have their own unique stories and histories of being found, and Triton is no exception to that. Triton was discovered by British astronomer William Lassell in 1846, which is important because it was found just 17 days after the discovery of Neptune, which is odd when you consider that many other moons were found long after their planets had been discovered, and some were even convinced that they weren't moons at first. But that's another story for another time. But the story is more layered than you may expect. This all started when John Herschel heard of Neptune's discovery. Interested in what this could all mean, he went to Lassell and suggested that he look for moons that might be around the planet. Lassell did so and discovered Triton 8 days later, which is interesting because he honestly wasn't an astronomer but a brewer. And Lassell spotted Triton with an aperture metal mirror reflecting telescope that he built on his own. The telescope was later donated to the Royal Observatory, Greenwich, in the 1880s, but was eventually dismantled. This is still an amazing thing because you usually hear of the legends using very special telescopes to find moons and planets, but Lassell just built his own and looked to the stars. If only everything was so simple. As for the naming of the moon, Triton is named after the Greek sea god Triton, the son of Poseidon, who happens to be one of the main Greek gods. The name was first proposed by Camille Lafleurion in a book and was officially adopted many decades later. Number 5. Orbits and rotations. Triton is unique among all large moons in the solar system for its retrograde orbit around its planet, i.e., it orbits in a direction opposite to the planet's rotation. Certain moons of Jupiter and Saturn also have these kinds of orbits, as do some of Uranus's moons. The difference, though, is that these moons are all much more distant and are small in comparison. The largest of them, Phoebe, has only 8% of the diameter of Triton. So for Triton to do this is very odd indeed, which has gotten the attention of many as they try and understand why exactly this moon has such an odd orbit. Triton's orbit precesses forward relative to Neptune's spin with a period of about 678 Earth years, making its Neptune orbit relative inclination vary between 127 degrees and 180 degrees. That inclination is currently 130 degrees. Triton's orbit is now near its maximum departure from coplanetary with Neptune's. Triton's rotation is tidally locked to the extent that as it goes around Neptune, it'll always keep one face oriented towards the planet at all times. In fact, its equator is near perfectly aligned with its orbital plane. Triton's rotational axis is about 40 degrees from Neptune's orbital plane, and hence, at some point during Neptune's year, each pole points fairly close to the Sun, which is similar to its sister planet of Uranus. As Neptune orbits the Sun, Triton's polar regions shift in looking at the Sun, resulting in seasonal changes as one pole shifts towards the sunlight. In 2010, these were seen by us here on Earth, kind of making it a rare sight. Triton's revolution around Neptune has become a nearly perfect circle, which is not something you'd expect to hear. But how exactly the moon was able to do that is a bit unknown. There are many factors that play into this, and scientists aren't sure how many work towards this achievement, though certain gases possibly slowing down the moon during its origin period to obtain this is likely. Another thing to note about Triton's orbit is that it is already closer to Neptune than the moon is to Earth, which absolutely is something to make note of because predictions are that 3.6 billion years from now, Triton will pass within Neptune's Roche limit. This will result in either a collision with Neptune's atmosphere or the breakup of Triton, which in turn will form a ring around Neptune at some point in time, which is something that would truly be something magnificent to witness firsthand, though it's doubtful that humanity will be around to witness it. This isn't the only moon in the solar system to have this eventual fate, but to have it happen with such a large moon is special indeed. though again it will not happen for billions of years. And there's another factor in regards to a moon with a retrograde orbit like this that must be taken into account. Before we continue to break down this moon of Neptune, be sure to like or dislike the video so that we can continue to make better content for you, the viewer. Also be sure to subscribe to the channel so that you don't miss any of our weekly videos. Number 4. Its capture. Moons in retrograde orbits cannot form in the same region of the solar nebula as the planets they orbit, so Triton must have been captured from elsewhere. For those confused, the solar nebula is the dominant theory of how the solar system was made. Gas and debris from the Big Bang eventually formed the Sun, and the gravity of the Sun eventually formed the planets, moons, and more. In regards to Triton, the Kuiper Belt, a ring of small icy objects extending from just inside the orbit of Neptune to about 50 AU from the Sun, is more than likely where it came from, which isn't too much of a stretch when you think about it, considering all the other objects that are known to come from there, and to have possibly come from there, including Pluto and other well-known objects. Triton is only slightly larger than Pluto and nearly identical in composition, thus making many believe that they are indeed from the belt, or at the very least close in regards to how they formed, even though only one of them was ever considered to be a planet, and should still be considered one. Regardless of that though, understanding the capture of Triton may explain several features of the Neptunian system as a whole, such as the eccentric orbit of Neptune's moon Nereid, and the scarcity of moons it has compared to the other giant planets. Triton's presence may have even led to other moons being dispersed among the stars instead of being captured by Neptune. There are two major theories or beliefs as to how Triton's capture might have happened. To be gravitationally captured by a planet, sufficient energy must be lost to be slowed down to a speed so that it won't be able to escape the gravity of the planet. An early theory of how Triton may have been slowed was by collision with another object. Given the randomness of space and the fact that other moons and planets have been pelted by rocks of various sizes over the years, this is incredibly possible, though what exactly would have struck Triton is unknown. Another idea, though, is that Triton was part of a binary system. When this binary encountered Neptune, it interacted in such a way that the binary broke up, leaving Triton with Neptune while the other half was sent away. Most think that this could be what really happened because it felt that Mars had a similar thing happen with its two moons and their capture. Binaries being very common among the large Kuiper Belt objects, this could be what happened. Some even saying that these kinds of events are common in regards to Neptune and its formation. But don't go thinking that this is the end, because simulations in 2017 showed that after Triton's capture might have been indeed caused by several collisions of certain kinds. You might find it interesting that we honestly don't know exactly how Neptune captured Triton, but in fact this is but one thing that we don't know about our solar system as a whole. There have been many questions about its formation, including the timing of formations of planets like Mars, how the Earth got its moon, and more. And it's another key reason why astronomers and scientists continue to study the solar system so that they can get answers to these questions. Number 3. Characteristics of Triton. Triton is the 7th largest moon and 16th largest object in the solar system, which is notable for various reasons, including how we look at the solar system as a whole. It comprises more than 99.5% of all the mass known to orbit Neptune, including the planet's rings and 13 other known moons, and is also more massive than all known moons in the solar system, smaller than itself combined, which is again very important when you consider how we look at the solar system and gauge things like these other moons. Now, as for Triton's surface, it's covered with frozen nitrogen. Only 40% of Triton's surface has been observed and studied, though, to be clear. However, based on what we know, it's likely that this frozen nitrogen does cover the whole planet. Triton's crust consists of 55% nitrogen ice with other ices mixed in. Water ice comprises 15 to 35%, and frozen carbon dioxide, dry ice, the remaining 10 to 20%. Trace ices include 0.1% methane and 0.05% carbon monoxide. Just as important, there might be ammonia ice on the surface, as there are indications of ammonia dihydrate in the lithosphere. Triton's mean density implies that it probably consists of about 30 to 45% water ice with the remainder being rocky material. An interesting balance, to be sure. What might surprise you, though, is that this moon has an unusually high albedo, reflecting 60 to 95% of the sunlight that reaches it. By comparison, the moon reflects only 11%. This in turn helps explain its low temperatures and why it shines so brightly. Models of the interior of the planet tell an interesting story, mainly in that the moon might not be too different from how Earth is constructed, as it has a solid core, a mantle, and a crust, potentially at least. Water comprises Triton's mantle, enveloping a core of rock and metal. There is enough rock in Triton's interior for radioactive decay to maintain a liquid subsurface ocean to this day, which would make it a very unique moon and something that many want to test out for themselves. Number 2. Atmosphere. Triton is one of a set of moons that honestly does have an atmosphere around it, but just because it does have one doesn't mean that it's one that can be likened to Earth. Triton has a nitrogen atmosphere with trace amounts of carbon monoxide and small amounts of methane near its surface, again very different from Earth as we have ours. Its surface temperature is at least 35.6 Kelvin, minus 237.6 degrees Celsius. This is due in large part because of Triton's nitrogen ice. An upper limit in the low 40s Kelvin can be set from vapor pressure equilibrium with nitrogen gas in Triton's atmosphere. This also means that Triton is colder than Pluto via these processes. Triton's surface atmosphere pressure is only about 1.4 to 1.9 pascals. Turbulence at Triton's surface creates a troposphere rising to an altitude of 8 kilometers. Streaks on Triton's surface left by geyser plumes suggest that the troposphere is driven by seasonal winds that are able to move more than you might expect. However, Triton's lack of a stratosphere and instead has a thermosphere from altitudes of 8 to 950 kilometers and an exosphere above that. The temperature of Triton's upper atmosphere is higher than that at its surface due to heat absorbed from solar radiation and Neptune's magnetosphere. Number 1. Cryovolcanism. Triton is not just a regular moon. Rather, it's a moon that has activity upon it via volcanoes. Not the ones you think about when you hear the word, but ones with water and ammonia, as opposed to liquid rock, which makes them cryovolcanoes, and not the kind we have here on Earth which shoot smoke and lava. Part of the reason that this is able to be like it is due to the valleys and ridges that Triton has over its entire surface. These features on Triton are endogenic, the result of internal geological processes rather than external processes such as impacts. Two large cryolava lakes on Triton seen west of Leviathan Patera. Combined, they are nearly the size of Kraken Mare on Titan, which is obviously quite large, and Titan itself has many interesting features like Triton that make it unique. One of the largest cryovolcanic features found on Triton is Leviathan Patera, which is roughly 100 kilometers in diameter and is so large it can be visible at the equator. Around it is a volcanic dome that stretches for roughly 2,000 kilometers along its longest axis, making it the second largest volcano in the solar system by area after Alba Mons, which is rather impressive and something that many want to study. The Voyager 2 probe, which has revealed all sorts of things across planets and moons, observed in 1989 a handful of geyser-like eruptions of nitrogen gas and dust from beneath the surface of Triton in plumes. But not just small ones that can reach 8 kilometers into the air. This means that Triton is one of the few bodies in the solar system on which active eruptions of some sort have been observed. More studying of these could lead to even more revelations about Triton, which could make it a place that is possibly landed upon by a rover or other device down the line. And should they be able to, the study of these cryovolcanoes could lead to interesting observations of their own. Thanks for watching. What did you think of this look at Triton and everything that has to do with it? Do you find Triton a bit more interesting of a moon now? How do you think humanity will look at the moon going forward? Let us know in the comments below. Be sure to subscribe, and I'll see you next time on the channel.